In this video, we're going to talk about the recycler view. Now, the recycler view is basically a more advanced and more modern version of the list view. Effectively, it's a distillation of what it means to be a collection of visible views in Android. So what I mean by that is it actually does considerably fewer things than the list view does, but the way it does it is a lot more flexible, and it enforces good practices by basically forcing you to use the view holder pattern. So basically, the recycler view is a more modern list view. And in this video, I just want to show you guys a quick crash course of how to use it, because we will be using the recycler view later on, or very shortly here in the creation of the app, to build up some of our other views instead of using a list view. So yeah, let's go ahead and get started. I'm going to go ahead and create a basic starter application with a blank activity, and I'm just going to keep all the defaults. So let's go ahead and give it a second to set itself up here. All right, so it popped up over there. Let's bring it over here so you guys can see it. And here is our basic templated project. So let's go ahead and just wait for it to figure out all of its stuff, and it's done. All right. So what I'm going to do now is the first thing I want to do is I want to introduce the recycler view to the application. So to do that, I'm going to go ahead and jump down into my Gradle scripts, and I'm going to locate the build.gradle that's associated with this app module. Remember, this build.gradle is our project, whereas this build.gradle is more of an overarching sort of solution, if you're familiar with Visual Studio. So inside of this Gradle file, what I'm going to do is down here at the bottom, I'm going to add a new dependency. And that's because the recycler view comes from a support library from Google. So what I'm going to do here is I'm going to say compile, and I'm going to say com.android.support:recycler_view, if I can spell, recycler view, all one word, -v7, and then I'm going to do plus. And the plus right here, IntelliJ is going to throw a fit about it, but the plus right here just means that I want it to always download the latest version of the recycler view. And I'm just throwing that in there. If I was in production, I might write something where I lock down to a specific version of the recycler view. But in this case, I don't really care. Let's just grab whatever version that it wants us to use. And in this case, what would generally happen here is a little sync now button would appear from the top, but sometimes IntelliJ decides to completely forget that it can sync Gradle projects. So what I have to do before I continue is close out of IntelliJ and open it back up. So I need to get this Gradle file to sync, otherwise it's not going to go off onto the internet and grab this jar for me and include it into my project. So I'll be right back. So now that I'm back, now I have my nice little Sync Now button up there. Make sure you click that. Give it a second, and it should be about done. Alrighty. So the first thing I want to do, again, this is going to be just a quick crash course in how to use the basic recycler view for basic purposes. What I'm going to do here is I'm going to jump into my activity main layout, and I'm going to replace the contents of this relative layout with an instantiation of the recycler view. Not surprisingly. So we're going to do android.support.v7.widget.recycler_view. Now, if you spell this wrong, you will get a runtime exception when the layout is inflated. You won't get a compile time exception. So make sure you spell that right. For its layout width, I'm going to give it a match parent. For its height, I'm going to give it a match parent. And I'm also going to give it an ID of activity_main_recycler_view. And that's it. So we gave it an ID, so we can go ahead and make sure that that we can access it from our Java class. So now let's jump over to mainActivity.java. And what I'm going to do here is I'm going to go ahead and nuke all of this code right here. Or basically, we're not going to be using the action bar in this example. So just to clean up the code a little bit, I'm going to get rid of all that. Now what I'm going to do is I'm going to go ahead and start kind of backwards. I'm going to go from the bottom up here. And the reason I'm doing this, it'll be pretty clear the reason why I'm doing this as I'm doing it, because you'll notice that there's basically a hierarchy of things that are required in order to work with the recycler view. The first thing that we need is a view holder. So I'm going to say private class, and I'm going to call this name list view holder, and it has to inherit from recycler view.viewHolder. In addition, you'll notice those squiggly lines appeared. We have to make sure that we implement a constructor that invokes the recycler view viewholders constructor. And we can do that all automatically by placing our keyboard cursor on the squiggles, hitting Alt, Enter, Enter, and when IntelliJ gets active, oh, I guess we didn't have to hit it again. Okay, so this is our view holder. Now, people who have been following up with the series, especially through our ListView mini-series, would know what a view holder is. But for people who don't, a view holder is basically a object that's responsible for holding references to all of the individual views inside of a ListView view. I don't know if I could have possibly said view more times in that sentence. Basically, you can think of a view holder as the individual items that appear in a list view, or a recycler view in this case, and you can think about them, view holders containing references to all the inner views. Like, let's say that we have a list view item that has a image and a text view at the same time. It has an image view and a text view, and so it displays an image and a text, a very common thing you would do. A view holder would hold a reference to that image view and hold a reference to that text view. So in that vein, what we're going to do is our example that we're putting together is just going to be a list of strings, a very simple example. So we're only going to need a reference to one thing, and that is going to be a public text view, and I'm just going to call this name text view. Then, because the view holder requires that we receive a reference to the view that this view holder represents, we will go ahead and establish our individual items, our individual views inside of the constructor. And I can do that simply by saying name text view equals cast to text view, item view, find view by ID. And in this case, I'm going to do r.id.list item name, and we'll just do name. So this ID does not exist yet, which is why it's appearing in red. It doesn't exist yet because we haven't created the corresponding layout file for our list view items yet. We'll do that momentarily after we finish up the first implementation of this code. Or rather, the simplest implementation of this code. Okay, so now let's go ahead and write our adapter. So just like list views, recycler views require an adapter. But the cool thing about recycler view adapters is they have a concept of a view holder. And you'll notice it significantly decreases the amount of code required in order to work with it. So what I'm going to do here is I'm going to say private class name list adapter extends. Now this is the cool part. Recycler view dot adapter. And then as a generic type parameter, I'm going to pass in name list view holder. So what did I do here? So I'm inheriting from the recycler view adapter, which is required in order to add this, use this adapter class as an adapter for recycler view. And you'll notice that I'm passing in a generic type parameter. And that's because the adapter class has a concept of a view holder. It's really awesome. It has the concept of a view holder built into it. So if we pass the type of our view holder into the type parameter list, then it will make life a whole lot easier. Because watch this. It's like magic. I'm going to hit Alt, Enter, Enter, Enter. And the reason I did that was to implement, or to have stubbed out, all of the methods that are required to be implemented by this abstract class. And notice these method signatures. Like, for example, we have our onCreateViewHolder class. Notice how it returns a nameless viewholder. We have our onBindViewHolder method, and notice how it returns, or it accepts, a nameless viewholder. So you see, by supplying that generic type parameter, we now have a significantly more strongly typed experience when writing our adapter. So now our adapter is tailored to a specific kind of viewholder. Okay, so before we implement this adapter, let's talk about these three methods. How do these three methods work with the recycler view? So let's start with this, get item count, because that's the simplest one. What does get item count do? Well, it does the same thing that a list view adapter would do. It returns the amount of items that should be rendered by this recycler view. In this case, we're just returning the default 0. We'll change that here in a second. Next up, we have onCreateViewHolder and onBindViewHolder. Now, these two things used to be one method. If you kind of think about recycler view as a more advanced list view, you can think about these two methods as being the getView method of a list view adapter. The first method instantiates a view holder for a given view. And the second one binds the data of a view holder for a particular position. So this one creates a view and a layout and a view holder, and then this one populates the view holder with data at the corresponding position. So let's go ahead and write this out. Before I implement these methods, I need some sort of backing data source. Now, I could just hard code all this stuff in. I could say, okay, we always have 10 items in this adapter, but that's not a very interesting example. So instead, what I'm going to do is I'm going to have an array list of strings that's kind of the backing data structure for this adapter. So I'm going to say private array list, or we can do private final array list in this case. Array list, not array, of string, and I'll call this names. Then I'm going to create a constructor, so name list adapter, and the constructor is simply going to instantiate my names list. Next up, it'll make more sense if I do it in this order. I'm going to say public void add name string name, and the add name method is going to be interesting. We're going to say names.add name. Now this so far should feel really, really familiar to people who have worked with ListView adapters. But I'm going to do something after this that will look a little crazy. I'm going to say notify, which you guys know that's how we tell the recycler view that our adapter has been updated, just like how the notify dataset changed is the same method that, or a similarly named method that we use with our list views view adapters to tell our list views to update themselves. Well, the recycler view actually has a couple more variants of it that could be more performant, but also allow cool animations. So the notify dataset change will say recycler view, update all of your stuff, right? Or we can be more specific. I can say notify item inserted. And here and then it asks me for a position. In this case, I'm going to pass in names.size -1 because the item that was just inserted is the second to last, or the last item now. And because we're 0 index, we take the size of the array and we subtract 1. So this is a case of the recycler view being a little bit more advanced than the list view already. We can tell it about something being inserted. We can also say notify item change, so only that item gets repopulated. We can notify item removed, we can notify item moved, and we can do ranges as well. So that's really cool because that allows the recycler view to do really cool animations right out of the box. Of course, like I said before, if you want the shotgun approach, the notify dataset change is what you want because that'll just tell the recycler view to update everything. All right, let's do our remove name. And in this case, what I'm going to do is I'm going to say int position equals names dot index of name. Then I'm going to say names dot remove position. Then I'm going to say notify item removed position. So not the most efficient code, especially considered we're using an array list and we're removing stuff. But this is an example, so it's not that big of a deal. Okay, so now that we have our data source, in this case, it's just an array of strings, not very advanced. Let's go ahead and implement these three methods. Now, the getItemCount method should be pretty obvious. Well, what do? We return how many items are in this recycler view. In this case, since our data source, our backing data, is this array list, we simply return the size of that. Now, what about our onCreateViewHolder? Now, our onCreateViewHolder should actually have been named onCreateViewAndViewHolder, because this method is responsible for inflating a particular layout. So what I'm going to do here, well, you don't have to inflate a layout. You could just instantiate a view directly in code if you wanted to. That would work as well. But in this case, what I'm going to do is I'm going to use the layout inflator to inflate a non-existent layout. Now, this layout doesn't exist yet. I know it'll show red and show an error, but we'll fix that here in a second. I'm going to say view equals getLayoutInflator. Now, this getLayoutInflator method comes from the nesting activity class. .inflate r.layout list item name will pass in parent for the parent parameter and false for attached to root. We'll complete this method simply by returning a new instantiation of nameListViewHolder, passing in our view that we just inflated as the parameter. So all we have to do is instantiate the view holder, passing in the view that we inflated, and the view holder will then, in its constructor, as you see right here, alias out the individual text view that we're going to be manipulating. So yeah, so far so good. Pretty straightforward. As you can see, it's already conceptually a lot cleaner than the list view is. So on our bind view holder, what does this do? Well, the first thing we need to do is get the data out. So I'm going to say string name equals names.get position. So this is just like how the get view of the list view returns the position of the item that we're currently wanting to render. That's what that position is. And in this case, because we have a one-to-one correlation between the position of the list item and the name in that name array, we can simply extract that particular name from that particular index, and we get the proper name. Now what we have to do is populate the view holder, which is pretty simple. Simply do holder name text view dot set text name, and that's it. So yeah, that is our adapter. As you can see, a lot less code than creating your own adapter with the list view, and a lot just a lot easier to read and understand. So now let's go ahead and see how we hook this up to an actual recycler view. So I'm going to say, well, I'm going to get my recycler view. I'm going to say recycler view equals cast to recycler view, find view by ID r.id recycler view. Now, the first thing I'm going to do is necessary. Now, like I said before, the recycler view does even fewer things than the list view does, which means we have to do so that those responsibilities that it delegates have to be fulfilled in some sort of fashion. So one of those responsibilities is how the items are laid out to begin with. Now, there's a variety of ways that the recycler view can lay the items out. In fact, we can control how those items are laid out. But what we have to do is we have to tell it how to lay those things out, and it doesn't come with the default one instantiated. So we have to invoke the set layout manager, otherwise we would get an error if we tried to run the program as it is. Now for the layout manager, we're going to instantiate a new linear layout manager. But as you can see here, we could also have instantiated a grid layout manager or a staggered grid layout manager. So let's go ahead and instantiate our linear layout manager, and that requires a context. So in here, we're going to say this as the context, which of course is a reference to the activity. Now we can instantiate and set up the adapter. So I'm going to say nameless adapter equals new nameless adapter. Then I'm going to say recycler view dot set adapter. So far, that's pretty much exactly what you would do when working with the list view. Pretty straightforward. We instantiate our awesome adapter, and we tell our recycler view to use it. Now what I'm going to do is populate the adapter with data. So I'm going to say for int I equals 0, I smaller than 200, I plus plus, and we're going to say adapter dot add name integer toString I plus name. Or let's do name first. And that's it. So, for at least this step of the example, that completes our main activity.java. Let's go ahead and jump down here to our list item name layout, and let's implement that real fast, because we definitely still need this layout implemented, and we also need this layout to have this particular ID. So I'm going to scroll one more time up here to the top of the file, so if you guys want to pause the video and take a look at that code, you can. Otherwise, we'll be moving right along. So to implement this layout, I'm going to put my keyboard cursor here in that red text and hit Alt-Enter, Enter, Enter, which will go ahead and it'll create me a new layout file in my app resource layout folder. Now inside of here, what I'm going to do is I'm going to go ahead and split these up here so they look a little nicer. I don't care about the orientation of the linear layout. In fact, I don't even care that it's a linear layout in this example. Let's go ahead and change it to a frame layout. I think that would be a little bit of a more appropriate choice given what I want to accomplish with this. Now, the first thing that I'm going to do is I'm going to create my text view with a width of mesh parent and a height of wrap content. I'm also going to want to make sure that my frame layout's height is a wrap content as well. Now, for my text view, really all I'm going to do here is give it a padding of 8dp and an ID of list item name name, which is the ID that our main activity is expecting. And I'm going to keep it like this, actually, because it's not complete quite yet, but it'll be an interesting enough example to show you guys why the recycler view, or some of the things that the recycler view won't do automatically for us. So if I jump back into main activity, you notice how now all the errors go away. So I'm going to jump over one more time into this layout, and then I'm going to go ahead and hit play, and let's see what this application looks like. We're going to notice two problems right off the bat when we open this up, but it'll serve as a good way of showing you guys what you need to do in order to make a recycler view behave like a list. Okay, so that's cool. Check that out. We have all of our names, and we can scroll down and all the way to the bottom, and we can scroll up all the way to the top. But a couple interesting things to note. First of all, where's that scroll bar? We don't see a scroll bar indicating how much further down the list we can go. Second of all, when I click on these items, notice how I don't get any feedback that these items are being clicked. See, normally with the list view, by default, when you click on an item, you'll get that really cool little ripple effect in Lollipop, or in earlier versions, you'll at least get a change in background. This is not the case for the recycler view. So we actually have to do a little bit more work to get that to work properly. It's not a lot, and I just wanted to stress this really quickly to people because it'll be something you might forget. Second of all, you'll notice that there's no scroll bar, which we'll fix very easily. And finally, you'll notice there's no separation between these items. That's because the recycler view doesn't do that for you like the list view. Remember how the list view has that nice little divider between each list item? The recycler view does not do that. So instead, what you need to do is you need to use what's called a recycler view adapter, which is a bit out of scope for what we're going to be doing in this particular video. But know that it is possible. All right. So now let's go ahead and fix those problems. Let's start off with the clicky problem. So what I'm going to do is I'm going to change the background of this frame layout. I'm going to give it a background of ? Android : selectable item background. So if you recall from an earlier video, this syntax right here when referencing a resource is referencing a variable resource that comes from the theme of the application. So this selectable item background will change depending on the overarching theme that our app is running in. However, we are not done yet. The reason we are not done is the frame layout by default is not clickable, meaning it's never going to be pressed and the background will never be triggered and the selector drawable will never be triggered to change the background. So what we have to do is we have to also specify clickable equals true. So make sure you do that. If you ever have a problem with the background not working properly in the recycler view, you probably forgot to set clickable to true. Okay, so that fixes that problem. Let's jump into our activity main and fix our scrollable problem. So for this, all we have to do on our recycler view is set our scroll bar's value. In this case, I'm going to set it to vertical. And really, that's it. So I told you the scroll bar one would be easy. All you have to do is set one property on the recycler view. I'm not sure why it's not enabled by default. It seems that in most cases you would want a scroll bar somewhere, but maybe not in some. I don't know. Either way, that's how you fix it. Let's go ahead and address one more issue here. I want to go ahead and address the row striping. To give, because like I said, building the view decorator is kind of out of scope for this video, but I do want to be able to differentiate between these items a little easier. So I want to go ahead and make sure that these items are striped, or zebra striped, where one item has a dark background, the next item has a lighter background, the next item has a dark background, and so on. Now, the way that I'm going to implement this is inside of the onBind view holder. And what I'm going to do is I'm going to say if position modulus 2 equals 0, which this code right here indicates if the position is even, then holder.nameTextView dot set background color to color.parseColor, and then in quotes, because this is a string, 22000000. Otherwise, holder.nameTextView set background. Now, this is not set background color. This is set background to null. So, a couple interesting points of the way of how I'm writing this code. First of all, you'll notice that I'm setting the background on the name text view and not the frame layout. That's because I don't want to affect the ripple effect that'll happen when I click on an item. You'll also notice here that I'm using black but with a very, very low opacity. So I'm using an ARGB value here, where these two nibbles are the alpha channel, that's the red channel, that's the green channel, and that's the blue channel. Or 1, 2, 3, 4, 5, 6, 7, 8. Oops, I added an extra 0. Glad I was showing you guys that. And anyway, and the reason I'm doing that is because when this the black is slightly transparent, you'll be able to see through it and see the ripple effect in the background. All right, let's go ahead and hit play. So now, a couple interesting things to note. You'll notice that we do indeed have the scroll bar. You'll also notice that we have our nice little zebra striping. Could probably be a little bit more performant. You might look for different solutions for zebra striping than using a transparent background. I just thought that looked cool for this example. And you'll also notice that we can now click on the items and we get that cool little ripple effect. Because right now my virtual machine is working on Lollipop, but if you were using an earlier version of Android, you would just get a different background color when you press down. Okay, so the last thing I want to do, the last thing that I think is incredibly fundamental to understand about recycler views is handling item clicks. Now, the recycler view, it should come to absolutely no surprise that the recycler view really has no concept of clicking on items. There is no set on item click listener in the recycler view. We need to write that ourselves. And it becomes a little tricky. Because what I want to do is I want to set an on-click listener for this view right here that I created in the onCreateViewHolder method. But that view, I don't know at that time what item it's currently looking at. Because remember, the views are reused. That's why it's called recycler view, by the way. Like, for example, this name 0 view, as I scroll down, that view is most likely one of these views down here. Which means, how do we handle a click event on this view when we don't know what item is being populated? Well, the solution, there's many solutions to this problem. My favorite solution for the simplest case is do it like this. I'm going to say view.setOnClickListener, and the onClick listener I'm going to pass in here is simply going to be new onClick listener. And for this, what I'm going to do here is I'm going to say string name equals cast to string view.getTag, and then I'm going to say remove name name. So for this example, all I'm going to do is invoke the remove name method with the name that this view was currently looking at when you clicked it. However, we're not done yet. So you'll notice that I'm using the view.getTag to get the current name that view is looking at, but now we have to make sure that the tag of the view is populated with the current name of the view that it's looking at. Now we do that by inside of our onBindViewHolder method, going ahead and coming down here and saying holder.itemView.setTagName. So you'll notice that I'm getting the item view field out of my view holder. That method or that field comes from the recyclerView.viewHolder that we inherited from in the namelist view holder. So now when the view holder is bound, we set the tag of the individual view to what name it's currently looking at. Then on the onClick, we extract that out there and do something with it. In this case, we do a remove name. It could be anything that we want to do here. So let's go ahead and hit play. And if I click on an item, like item 12, notice how not only does it disappear, but it also, we get that nice little animation. Now there's a couple more things we can do to make this a tad bit more robust. For example, you'll notice that the zebra striping doesn't get updated when we remove the item. We can fix that really easily on this remove name method by saying notify item range changed, passing in position for the start and names.size for the end. So what I'm doing here is I'm saying, okay, notify that the item was removed, and then go ahead and only update the items that are from this position onward, and then it'll reapply the zebra striping for us, and that'll fix that problem. The next problem is when we remove a name, it's possible to double click and click on the view twice, even after it's been removed. And we can fix a potential exception from happening here by saying if position equals -1, return. Meaning, if the name wasn't found in the names array, then just go ahead and early exit out of the method. So now when we hit play, those two those two issues should be resolved. So now I can remove the item, and notice how the zebra striping updates when the item is removed. And you'll also notice when I double-click an item, we don't get an error. Anyway, this was just a really, really quick crash course into the recycler view. We are going to see a more advanced usage of the recycler view here shortly. And then finally, the most advanced uses of the recycler view we're going to be writing is going to be the inbox of the application, the main activity, which will show two types of data and headers and be a grid. So that should be pretty exciting. So yeah, I guess we'll see you guys in the next video.